Hello, in this section of the tutorial we're going to learn how to use this calculator to graph sequences. And when we call sequences, we're talking about mathematical sequences. And so, if you haven't studied this before in math, if you don't know what a sequence is, then it's something that you'll usually get into when you get into the latter part of an algebra class, and maybe an algebra 2 class. A sequence is basically a list of numbers. Literally, that's all it is. It could be, when you were in third grade and you had the problem on a worksheet, where it had, 2, 4, 6, blank, 10, and you had to fill in the blank. Well, you were looking at a sequence of numbers, and you were asked to fill in the blank. You were using your, brain to figure out the pattern and to fill in the blank for the number. And so a mathematical sequence is similar. It's similar to a function in that usually, a function is f of x, and we stick in values of x. And then we get values of f of x, the function that we get back, y. In other words, you can call it y. And we plot those on a graph, or we can make a table. Well, in a sequence, when you're talking about sequences, the independent variable is not x. We usually call it n. The independent variable is usually called n. And we have a function usually that we define. And that function, so we might have, n squared, for instance. So we would plug in values of n and get n squared. But the difference between that and a function is that for functions, they're continuous. In other words, any value of x you want, you could put 1.795 in for x and calculate the function value y, or f of x at that point. But in sequences, you're only constrained to the whole numbers. 0 for n, 1, 2, 3, 4, 5, 6. The numbers in between those whole numbers have absolutely no business belonging in when we're talking about sequences. So basically, you can sort of think of a sequence as like a function, except it's only defined at the whole numbers. So in some respects, it's simpler than a function and easier to calculate. But there are some differences, and we'll talk about that in a second. So basically, we're going to use this calculator to input sequences in here and show you how to plot them. You're going to find that it is almost exactly the same way to do it in this calculator as it was to plot our functions and to look at our functions. You're going to be able to use the table to look at values in a table form. You'll be able to graph them. You'll be able to zoom in and out. You'll be able to do basically almost all the same stuff. It's just that it's not a continuous function. It's going to be a series of dots, because for a sequence, we don't have a continuous function. We have only evaluated at those whole numbers. So let's stop talking about it and let's jump into it. First thing you need to do is go into the mode menu. And you'll see down here that we are currently in function mode. So when I go to y equals, these are the functions that I have already defined. So let's go back into the mode menu. And to put ourselves in sequence mode, we have to go here. We're going to talk about these in a second. This is parametric mode. This is polar mode. This is sequence mode. So we want to hit enter here. Now we're in sequence mode. So we'll go ahead and jump out of that. And now when we go try to input our equations that we want to plot, which now are sequences, we hit this. Notice it looks totally different. It doesn't have the familiar y equals stuff, because when we input sequences, we have to do it a little bit differently. Okay, so let me go down here and show you. First of all, the calculator does a pretty good job of being able to let you do some work with sequences, but it is a little bit limited. You can only plot 3 sequences, and they're labeled U, V, and W. And you've got the same sort of options that we talked about before with functions. You can change the look of the lines, the shading, or you could have a different spacing dots or whatever to make them stand out a little bit differently. It's the same as when we talked before about plotting functions. But we only have 3 different sequences that we can input and that we can look at at once. So it's a little bit more limited there. Now, all sequences are a function of the variable n. And so notice that when we were inputting equations earlier, f of x is x squared or something, we always press this button to put x in. But because the calculator is now in sequence mode, when you press this button, let me press it right now, x doesn't pop up there, n pops up. So that's why this button is labeled with so many different things, because depending on the mode you're in, if you're in function mode, it's going to put an x there. If you're in sequence mode, it's going to put an n there. If you're in parametric mode, it's going to put a t there. And if it's in polar mode, we'll talk about later, it'll put a theta there. So let me delete that for now. And just know that when you want to input n, you put it here. So instead of f of x is x squared, you might put u of n, u being the function name, u of n, you might put n squared. But for now, let's just put n instead of n squared. Let's not get too complicated here. Now, if you leave all this stuff blank, what's happening here is in min, this is the initial value of not the initial value of the sequence, but it's sort of like the very first value of x, so to speak. If you were talking about a function, this is the very first value of n that you're going to have. So in the end of the day, if you study sequences, you remember that when you write them down, you might have, if we're talking about the function u, we might have u sub 1 or u parentheses 1 and when n is equal to 1. And then we might have u when n is equal to 2, when n is equal to 3, when n is equal to 4, when n is equal to 5, and so on and so on. Nothing in between those whole numbers because sequences only deal with, when you evaluate these guys at those whole numbers. So in min is telling you where to start. It's telling you, in this case, we want to start with n is equal to 1. If our sequence started when n was equal to 5, then you would put a 5 right here, and then the sequence would begin counting at 5. But almost all the time in your textbook, you're going to have 1 here, so just pretty much leave it alone. Now for this very simple sequence, I'm going to leave u of n, I'm going to leave it equal to n. And what this is basically going to say is that this is a super simple sequence. Basically, when n is equal to 1, which is the first value, then the first value of my sequence is going to be equal to 1 because it's equal to n. When n gets to 2, then my sequence at that point, when you evaluate it at 2, is going to be equal to 2. So this is just like a function. When n is equal to 3, my sequence will be equal to 3. When n is equal to 4, the value of the sequence will be equal to 4, and so on and so on. So if we don't do anything else here, and I hit graph, which I'll do in a second, you'll see that this is exactly true. Now this third thing down here, we don't really have to put here, we don't have to do anything with because of the way I've defined my sequence. Since it's just a function of n, and I know that n starts at 1, I don't really need to put anything else here. I'm going to show you in a minute when you will need to put something here. So for now, let's hit graph. And it's going to go, and you'll see a nice little dotted line that appears right here. And so if you kind of use your imagination, if this is the n-axis, so it used to be the x-axis, but now this is the n-axis, and this is u of n, which is the sequence evaluated at that value of n. So when n is 1, the sequence is equal to 1. When n is 2, the sequence is equal to 2. When n is 3, the sequence is equal to 3, 4 and 4, and 5 and 5, and so on and so on. The reason it's that way is because I've set my sequence up to equal n. Whatever value of n I put in is what I get for my sequence. So you can clearly see that here. Now, instead of looking at a graph, you can also look at the sequence in terms of a table, which is really useful for sequences. So hit table, and you'll see the same thing happening. When n is 1, u of n is 1. When n is 2, u of n is 2, 3 and 3, and 4 and 4. And that's just because that's the way I've set my sequence up. Okay? Now, if you go in here, and instead of n, what if you make it n plus 2? Let's say that's my sequence. So whatever value of n I'm on, I just add 2 to it. And if I go back to table view and look at it, then the same thing you'll see. When n is 1, u of n is 3. When n is 2, u of n is 4. So you can really think of this almost like a function. It's just that this is not defined for anything between any of these numbers. It's only defined at these whole numbers, right? And if you graph it, it'll look like a line, but it'll be in a little bit different position because of the fact that it's there. Now let me also tell you that when you have this guy here, you can trace this sequence just like you can trace the functions. And you can scoot along here, but notice it's jumping only from point to point. So when n is 5, n is 6, n is 7, and so on and so on. And that's because this function is only, it's not a function, I keep calling it a function. This sequence is only defined at these values. It's not defined between these points. You can go into the zoom menu and you have all of the same things that you can zoom in and out just like we could before. So I'm not going to go through all of those. Everything applies from what you've learned before. You can zoom in, you can zoom out. So let's zoom out a little bit. Let's go to number 3. Hit enter to zoom out. And so we've kind of gone up here and zoomed out on the calculator. And when you go and trace, when we hit the trace button, then you'll see 3, 4, and it's 5, 6, 7, 8, 9, and so on. Now notice when we did this, the sequence doesn't continue on, and that's because you need to go into the window menu, which is defining your scales basically. And we said that in this window menu, it behaves very similar to the other, when we're using it for functions. But in this case, you can see n min is set at 1, which is what we set it to, but n max, we're only letting it go up to 10. So let's change that to, 20. And let's go back to the graph and let's see what happens. And you can see that the sequence continues farther, and you'll be able to trace on down through there. So you're able to zoom, you're able to look at this guy in terms of a table, and when you scroll down here past 7, you'll be able to keep going and see how the sequence progresses. And if you had another sequence that you put in here, maybe you want to put n squared, so let's put n squared, then you can look at both of these tables simultaneously together, and you'll see that it puts them side by side just like before. Now, one neat thing that you can do with this, just like you could do with the functions, is if you go into the y equals menu here, actually it's in the table set menu here. If you go up into the table set menu here, then you have the same kind of thing. You set the table up at 1, you have an automatic delta, but if you change this independent variable to ask, which is what we did before when we talked about functions, and then we go back to the table, then everything is blank just like before. So I can put, what about when n is equal to 5? And then it'll calculate the value of both of these sequences at that point. What if you put when n is equal to 44? Then you can stick that guy in there. Now look what happens. If you put a value of -2 in here for n, and hit enter, you're going to get an error. And that's because sequences, they don't make any sense when n is less than 0. So keep that in mind. Let's go back to table. And the same thing is going to be true if you go negative. So just keep that in mind. It's something that you really need to be aware of. So don't worry about if you get an error there. It's just the way it's set up to do that. Okay, so let's go back into table set. And let's change it back to auto, which most of the time you'll probably leave it in auto. And just to kind of drill it home, if you go back to the mode menu, remember before we were able to look at a graph and a table at the same time, and you're able to do the same thing when you're in sequence mode. So if we hit GT for graph table and then go back to graph, then we will see both of these sequences plotted here. One is more spaced out dotted lines because of the way it's drawn there, and the other guy is over here. And we'll be able to see both of these guys in table form there as well. So if we go back here, let's get rid of this second one just to make it a little bit easier to see. And you'll be able, you could zoom in here, you could zoom out, you can do all the same things, and you'd still be able to see your table here at the exact same time. So that's a pretty useful thing. Now there's these things that we've been talking about so far. These have been pretty simple sequences. Let me go ahead and put the calculator back in full screen mode just so we can continue on. These have been pretty simple sequences up until now. It's basically been a function of n. But sequences really get a lot of their power because you can have what we call a recursive sequence, where one element of a sequence might refer back to a previous element. So for instance, u sub 2 might refer back to u sub 1. Maybe you're adding them together. So you can you can create a sequence by adding together previous values of the sequence, for instance. And so to do something like that, maybe you had, maybe you were going to say that u sub n would equal the previous value, u sub n minus 1, and let's say you were going to square it. That's a pretty easy one. So the way you would input that, in order to do that, you need to actually write u and then n minus 1. The buttons for that are right here. It's not a capital U in green. It's the little bitty u in blue here. There's a V for the next function in blue here, and there's a W for this one here. So you need to hit second function 7. That's going to put a U there. You need to open your parentheses up, and you literally need to type n minus 1. And you can put a parenthesis there. I'm going to go ahead and enclose the whole thing in parentheses just to make sure that we're squared away. So I'm going to hit insert, and I'm going to put another parenthesis there. And I'm going to go to the end right here, and I'm going to square the whole thing. So what this is telling me is that for whatever value of the sequence I'm looking at, I'm just going to look at the previous value and square it, and that's going to be my new value. You'll understand when we see the table. Now, in order to do something like this, because I'm referring to a previous value, I need to tell the calculator what my very first value of the sequence is, u min. in other words. I'm sorry, u of n min. So when n is equal to 1, what is the very first value? This is what this is telling me. Usually in your algebra books, when they give you a sequence, they'll tell you what the sequence is, and they'll tell you what the first value is of the sequence. So this is what this is. So in this case, let's say the first value of the sequence is 2. Okay, and let's go ahead and put this guy in table. Let's go take a look at a table and see what happens. So you see what's going on here. When n is equal to 1, then the value is equal to 2 because I told it that that's what the value was equal to. See, this is what this is right here, 2. When n is equal to 1, the value of the sequence is equal to 2. That's what that is. So let's continue on and look. When n is equal to 2, my function is telling me, look at the previous value and square it. The previous value of the sequence. So here, when n is equal to 2, the previous value of the sequence was 2, and I'm going to square that and get 4. Don't forget how we wrote it. We said, whatever value of n you're at, look at the previous value of the sequence and square it. And that's what we're doing here. Now, what about when n is equal to 3? So it's telling me for the sequence to look at the previous value of the sequence here and square it. So 4 squared is 16. And so the pattern continues. When I have 4, look at the previous value of the sequence and then square it. And so that's called a recursive sequence. So you can enter into the calculator almost any sequence in your algebra book just by doing that. And you can graph it instead of looking at a table, but notice we got overflow, and that's because eventually we got to the point. Let me go back here to our table. Eventually, you see how our numbers got really, really big because we kept squaring and squaring and squaring and squaring, and it got really big. And that's because our window was set to 20. So let's set our window down to something more manageable, like let's just do 7. We'll hit enter there, and then let's see if it'll graph it now. And it will. And if we go into zoom, we can go to zoom fit 0, and let's see what happens here. And notice we got something a little bit weird. We have all of our dots down here. I don't know if you can tell, but there's a dot way up here. So if we hit the trace button, when n is equal to 2, we get 4. When n is equal to 3, we get 16. And it goes up and up to really big numbers. And the reason this graph looks so weird is because when n is equal to 7, the answer is huge. So if we go back into our window, just for the purpose of illustration, let's change this down to 4. Or actually, let's change it back to 3 just so we make sure we can fit it all in there. We go to graph, and then we go to zoom, zoom fit, so we go to 0. Let's see what happens. We should have something a little bit more reasonable. And so if we hit trace, when n is equal to 1, we get 2. When this point here, when n is equal to 2, we get 4. And when n is equal to 3, we get 16. And of course, you can zoom out. You can hit 3 and zoom out, and you see something a little bit more reasonable. So you can trace them. It's just that because they're not, the lines aren't connected, it gets a little bit cumbersome to take a look at. The table is really a lot more useful with the sequences, especially when you can enter in the values and have it calculate that. Now there's one more thing I'll show you, and that's the famous Fibonacci sequence. It's something that you probably learned about in your algebra class. It's a recursive sequence, and it basically takes and adds up the previous 2 values. Okay, so the way you do a Fibonacci sequence is you say u of n minus 1 plus u of n minus 2. And you put it in there like that. So this is a Fibonacci sequence. Basically, at whatever value of n you have, you take the 2 previous values, which I made a mistake here, it looks like. You take the 2 previous values, basically, and you add them together. So what we want to do here is we want to say u, and then parentheses, n minus 2, like that. That's what I'm trying to do. Okay, now let's go into window, and let's set it equal the n max to 10. So we'll let it calculate 10 values of n. Now I want to go back here and show you one more thing. Because we have it recursively defined, we have to tell it, not only do we have to tell it what the first value is, but we have to tell it what the second value is of this sequence as well, because notice that we're telling it to add the 2 previous values together. If I don't tell it what the first 2 values are, then it's not going to know what to do. So if your sequence just references the n minus 1 term, the previous term, then you only need to tell it what x min is equal to the very first term. We just did that just a second ago. But if you're referencing the previous two terms, then you need to tell it what the first two initial values are. And so the way you have to do that is you have to put a curly brace, and it's a little bit quirky in this calculator. You have to put them in reverse order. For the definition of the Fibonacci sequence, n is equal to 2, the value is defined to be 1. And for n is equal to 0, the value is defined to be 0. And you have to enclose it in these curly braces. And like I said, you have to do it in reverse order. This is n is equal to 2, the sequence is equal to 1. And this is n is equal to, n is equal to 1, the sequence is equal to 1. And when n is equal to 0, the sequence is equal to that. And so that's basically what you're going to do for the Fibonacci sequence. So when you go into table mode and take a look at it, actually there's one thing I didn't do. For the Fibonacci sequence, that's defined to start when n is equal to 0 as well. So n starts at 0, first value is equal to 0, second value is equal to 1, and we're basically adding the two previous terms together. We go into the table, and if you look in your algebra book, this should agree with what it claims the Fibonacci sequence is. So we go at the value of 0, the answer is 0. So the sequence goes 0, 1, 1, 2, 3, 5, 8, and you can keep calculating on and on and on. It's a famous sequence that's been studied in math for a long time. If you've never heard of the Fibonacci sequence, don't worry about it. It's just one of those examples that you show just because it's a recursive sequence in two that recurses twice. In other words, it references the two previous guys here. And of course you can graph it too. You can try, and you can see it starts to climb up like this, and you can trace it and on like that. So that's a pretty good introduction to working with sequences in the calculator. It's not something you're going to do that often, to be honest with you, but it's something that you might need. And just remember that you need to first put the calculator into the sequence mode, and then when you go to the graph menu here, you need to tell it what you're starting at. Is n starting at 1, or is n starting at 2, or is n starting at 0? You need to type your sequence in. This is what you would typically have in your book, is the definition of the sequence, and then you have to give it some initial conditions for the first term or two. In this case, it's 2 terms because I have 2 references here. And so if you're referring to previous terms, if you're not referring to any previous terms, if your sequence is just defined in terms of n, then you can leave this blank. And once you set all that up, you can go into the table. You can take a look at the values. You can even go in and change the on table set. You can change to ask, and that will allow you to input values of n and have it calculate values of u of n. You can have 3 different sequences at once. You can't have any more than that. And also, this calculator doesn't do any recursions past the level of 2. So this is the n-1, this is n-2. It doesn't go any deeper. It doesn't do n-3 or n-4. It's just a limitation of what the TI-84 can do. But you can do that. You can also go split screen so that you can look at your graph at the same time you look at your table. It's neat if you're just trying to get values of your sequence. A lot of times when you're doing this stuff, instead of calculating it a whole bunch of times manually, it might make more sense to put it in the calculator and then just go into the table, and then you can put in 10 different values and calculate the values of your sequence like that. I hope you learned something from this lesson. Play around with it. Input some of your sequences. I think you'll find that it's not that big of a deal, and it will save you a lot of time, especially if your problem is focusing on this material.